Hello there, team, and welcome to another update on the volcanic situation occurring in Iceland. I'm Geology Professor Shawn Willsey. Thanks for joining me. Today is Saturday, April 27th. It's about 9:30 a.m. here Mountain Daylight Time, 3:30 in the afternoon over in Iceland. And we're going to look at some of the data, some of the latest news coming out of Iceland. Thanks as always to Amanda Joe, who helps me compile and find some of these news stories, helps me kind of get myself organized as I put together these updates. So as you can see here, the eruption is still progressing as it has for the past several weeks, with one primary spatter cone as the active vent for this lava that's erupting at the surface. So we have the active spatter cone. At the base of it here, a little hard to see with all the gases swirling around there, but we have a conduit coming out of the base of the cone, and that's feeding a small, somewhat stagnant lava lake pond, a slowly flowing channel system here. That lava does continue, though, further south, as we found out. It travels underneath the solidified crust in a lava tube system, and that is feeding some of the inflation we see at the more southerly end of this flow. Now, it's not as extending as far south as it did early in the days of the eruption, but it's inflating, and we'll talk a little bit more about that as we go. Just to give you a little bit of context, it's hard to see what's going on during the daylight, especially in the middle of the afternoon. The incandescent glow of the lava is a little hard to see, but if we roll the time bar back a little bit to many hours ago, earlier today, you can see a little better idea of where that lava actually is erupting from the spatter cone crater. These intermittent bursts of lava that just coat the flanks and the rim of the spatter cone, building its size up. Also, periodically we get collapses into the pit. So the inside of this spatter cone crater is a very sheer-sided, steep-walled feature. And then you can see the glow coming out here. All the gas coming out of the southwest side is because there's a conduit from the crater, a tube, if you will, that feeds this surface flow that comes out the base here. And so there's a lot of gases escaping through there, and that's why we're seeing so much gas coming out that side. So just kind of scrolling ahead a little bit here. That's some cool lighting there. Look, as the sun's coming up. That's spectacular. Yeah, so there's some other views here. And then we kind of get to the daylight hours where it just looks like it's kind of huffing and puffing in terms of the gases coming out of the volcano. So that's our situation now. So simultaneous with this eruption, we also have the area above the magma body, which is a little bit to the west under the Svartsengi power plant in that region by the Blue Lagoon. We also have that area inflating. So we have had inflation or uplift of the ground from that rising and accumulating magma source for about 3, maybe almost 4 weeks now, since the early part of April. And that seems to be ongoing. And all of this is taking us to some future event. We don't know when, and we don't even know exactly what it will look like. All we know is that the inflation cannot be sustained indefinitely. And because we have an active eruption, we have a conduit for that lava to escape. There's some different scenarios as to exactly what's going to play out. So we are in uncharted waters, a little bit different than what we've seen over the past few months there in Iceland. So let's just go to the Met Office update, and let's hit some of the highlights here, and then we'll look at some of the other data that's taking place as well. So this is from yesterday, April 26. So the magma accumulation in the storage zone is approaching about 10 million cubic meters of magma. We know that in the past, over the past few months, anywhere from 8 to as much as 14 cubic million, or 8 to 14 million cubic meters of magma was the threshold that triggered an eruption. Well, we don't know if it's going to go much further than that because it is actively erupting, albeit at a fairly slow rate. But the big question I think a lot of folks would have is how much can it store and also erupt? Like, is the storage now larger than it was before? Is it the same? Is it potentially smaller? And those are some of the unknown questions. So part of the lava bed near the defenses to the east of Grindavik continue to slowly thicken. So that lava flow that progresses off to the south from the spatter cone is actually inflating and thickening. So it's not traveling further away per se. It's more or less pooling up, but thickening itself and growing upwards, if that makes sense. There's been some thoughts and confusion, maybe not confusion, but there's been some concern about if that thickening, inflating lava flow could potentially override the berms and threaten some infrastructure there. And to maybe answer that, I'll actually skip ahead to a news story that I just found here. So we have a little tongue of lava that is over the top of the berm near Grindavik. But according to this story, there's not much danger from it. So let me run you through this a little bit here. So you can see just this little tiny bit of lava that's overtopping those defensive berms. It says here it flows quite slowly. So far, there's no danger. It's this segment right here. Let me make that a little bit bigger. So these are the defensive berms shown in orange and green on this map. Here's the town of Grindavik. And here is the January 14th lava flow. So this is an older aerial image because it doesn't show the eruption that began March 16th, which carried lava about down to here. But you can see they've sort of identified these different barriers. So this L12 barrier is where this little lava tongue is. So continuing on with let me zoom that out a little bit, with this update. There's no sign. But they say there's no sign of it stopping, but it's barely moving over the top, according to this article. Quote, it's a small piece of lava that's just rolling across the park meaning the berms, cold lava shaped like that that's pushing over. So it's completely minor and we're not worried about it right now. So they're kind of monitoring it right now. And so I don't know. I think my take on the whole thing is that, we're probably a little bit more concerned at this point about what happens next versus this lava flow field that is potentially thickening and inflating. So this is the segment here. This is my version, my Google Earth version. Let me get it all on the screen there. From the eruptive vent, and then you can see in this teal green here, that flow field that came down to here. So apparently somewhere in here along this berm or barrier is where it's barely just kind of spilling over. But I think before we get too worked up about the lava thickening here and inflating and possibly coming over the top of the berm, now that is a concern. I think the more imminent threat would be what's the inflation eruption dynamic? Where's that going to go over the next week to 2 weeks? I think that's the more pressing concern as opposed to the thickening of the flow field there. But let's go back to the Met Office update. Land rise continues. If magma accumulation continues at a similar rate, there is a greater chance that the power of the eruption on the Sunux crater series will increase significantly. So if we keep that same vent open, that spatter cone, we might see a greater output of lava as that inflation and pressurization in the subsurface manifests itself at the vent, if that's what actually takes place. So they talk again, the lava flows a short distance to the south in an open lava river, but further in closed channels. The part of the lava bed near the berms to the east of Grindavik continues to thicken slowly. And then we have a couple graphs here. Let's just go to this one here. So this is basically showing us all the prior eruptive events that also coincided with, well, some were eruptions and some were intrusions, but basically areas where we had uplift, right? So on the x-axis here we have days since the last event, and the y-axis here is magma accumulation in the subsurface, okay, in millions of cubic meters. And so you can see all these past events here. I guess the oldest one here would go back to, the purple one here, which was late October into early November, when we had that intrusion and all the earthquake activity. So that ended, you can see the square here. That did not end in an eruption, but that ended with a intrusion of magma. And we had deflation right after that. So magma left the storage chamber, moved off to the east, and then actually stopped a little bit. And then following that, we had, I guess that'd be the blue line here. We had magma continuing to cause inflation for almost 29 or so days, 28 days, and then that did erupt or did culminate in eruption on December 18th. Moving forward over time, that would be the green line. So then after that eruption ended, magma inflation began again. And about 25 or so days, 26 days, we had the January 14th eruption. That only lasted a few days, but soon thereafter, inflation began to resume again, shown by the yellow line. And about 23 or so days, that culminated in an eruption. And that was the February 8th eruption. And then the light blue line was inflation that began right after that eruption, which again only lasted a few days. And then that ended with an intrusion event on March 2nd. So that magma did not make its way to the surface, but there was some earthquake activity, and the magma pushed into a new region in the subsurface. And then after that one, with the orange line, we had inflation again. And that culminated with the eruption that began on March 16th. And since then, now we're to the red line here. This is where we're at now. We've seen, a much less steep trend in terms of magma volume because we've been erupting lava at the surface the whole time. But nonetheless, the inflation has continued. We're approaching day 40 or so. And actually, we might be there since this goes up to the 25th of April. And so the question here is where does this go, right? If we have an eruption, we have an ongoing eruption, but does this result in increased activity in eruption? Does it result in another vent possibly opening up somewhere? Is there another intrusion into the subsurface that's going to take place as the magma storage zone continues to pressurize and fill? And so you can see we are in, these ones all looked very similar. Similar trends, similar behaviors, but now we're in this very different area of this eruptive cycle. And so things are looking different, and that's why the projections and opinions vary so widely across the board. So I think, let's see, so they just talk again about the two possible scenarios here. New fissures open up and or the existing fissure expands due to a sudden increase in lava that could be comparable to the initial phase of the last eruption. And this could happen with very little or no notice because we've already established that pathway so that magma can move through there fairly unobstructed. It doesn't need to break rock. And if it's not breaking rock, it's not generating earthquakes. And earthquakes are, of course, one of the signals we tend to see when new vents are forming. When a new vent is going to open up, we will see seismic activity that lets us know that that is a possibility. And here they talk about that it's possible that the magma flow, coming up into the storage zone could slowly increase, right? The surface spatter cone could increase its output to match the input of the into the storage zone, and then that kind of balances everything out. And although that's a possibility, I don't know. I just don't know if that actually will happen. So we'll have to see moving forward. So that's our Met Office update. If we look at earthquake activity over the past 24 or so hours, you can see not a whole lot of activity, but there are a few quakes, tiny ones, of course. That's a 1.1 there near the eruption site. So these are all pretty close to where the vent is right here. But again, just 4 or 5 earthquakes over 24 hours. Nothing alarming, nothing indicative of anything else taking place. So the earthquake activity is pretty quiet and certainly not indicating that another vent's going to open up or magma is moving up towards the surface in any location here. If we look at the past week, same sort of thing. These red dots here, those are some of the ones that have happened over the past 24 hours. These are color-coded by time, so red, orange, yellow, green, and then blue, depending on how recent it is. And then, of course, the size of the dot indicates the magnitude. So we've always had, throughout this period, just these scattered quakes over here in the Fagradalsfjall region, and then we're getting a couple here near the eruption site. But again, not enough clustering, not enough activity to warrant any sort of concern at this point. But of course, this can change literally within a few hours. So we'll continue to monitor the earthquakes as they are a very good indicator. If we turn now to the GPS and go to the latest run of data from the Svartsengi station, we can see that uplift continues quite strongly. And so we did have a few days in here. I think that was my last update where there were 3 dots, but that time that was the most current data points we had that were kind of flatlining. But we've seen since that time we can see that there's been a trend upwards, and so there was more gradual uplift happening early on after this eruption began on March 16th. But since then, the slope's been a little bit steeper, not quite as steep as what we've seen in the past. But still, uplift continues, and so we've seen a good, 100 millimeters, 10 centimeters of uplift total, I would guess, since this eruption began on March 16th. So having an eruption occurring along with the inflation of the magma body is something quite new, and that's sort of the uncharted waters, or this just new behavior that we haven't seen in the past. And there's a nice little article that goes with this, never seen before in this country nor elsewhere. Let's run through this a little bit. So Paul Einerson, a geophysicist, he says the development indicates the magma system does not look quite the same as experts have so far thought they knew. So everything sort of changed. I think it might have changed around March 2nd with that intrusion. I think the plumbing system might have been altered. And then when we had this eruption on March 16th, we had this very different type of behavior. So, quote, he says, "This is the first time we've seen something like this. There is no experience to build on what this may mean for the future." He says that such behavior at the roots of the earth has never been seen before in Iceland or in any other country. And I certainly don't know if that's completely true, but to my knowledge, it is pretty odd and rare to have both these things going on at the same time. And so that's kind of interesting in and of itself, to have this type of behavior taking place. I did get an email. Let me just read this real quick. I have a friend, a colleague who used to work for many years at the Hawaii Volcano Observatory, and I kind of told him what was going on here. And he says, this is his email to me: if GPS suggests inflation while an eruption is ongoing, then it's probably, as you say, there's a constriction in the feeder conduit to the surface. So that's one of the models I proposed. One of my last updates is there was a constriction, and he tends to agree with that. He goes on to say, "I think that at some point something is going to have to change to accommodate the building pressure. We saw this at Kilauea 2, inflation at the summit, and at Pu'uo'o, while the discharge from the vent was dwindling. We also saw instances where inflation at the summit was matched by an increase in discharge. In both cases, more was coming into the system than was getting out, resulting in inflation. The corresponding result was that eventually the system changed and new fissures opened up. The 20 eruption at Kilauea had the same lead up." So based on what he saw in Hawaii, there's a good chance that we will see potentially some new fissures open up once this thing becomes sufficiently pressurized, reaches whatever volume of magma is necessary for this thing to actually produce more activity than what we're seeing right now. So this is a nice article as well. I'll put this one in the video description. And so I think this is interesting. And then let's see, we looked at that. And then I guess finally, the last thing I have here is just another news article. They're just asking people not to walk out to the spatter cone or to the flows, especially given this sort of new uncertainty about where this thing's going to go. That if we do have either increased eruptive activity through this vent or new vents opening up, there wouldn't be much warning time. We might not see a lot of earthquake activity. They might not have time to get, law enforcement or folks down there to warn people to get out of the area. So, so a quote here from Benedict Olfigson: "A 2 to 3 kilometer long fissure may open with little notice, which can create considerable danger." So we'll have to see where this goes as we move forward, team. I wish I had more answers for you, but nonetheless, it's fascinating. It's a great learning opportunity. Wherever this situation goes moving forward, we're going to learn from it. Maybe it'll be something we've expected. Maybe it'll be something unexpected. But nonetheless, the good news is in Iceland, the town is evacuated. There's no threat to human life at this point, and they've pretty much done all they can to try to protect infrastructure. So at this point, it's just a situation of waiting to see what Mother Earth throws at us and what sort of eruptive dynamics ensue, and then just taking it from there. So I'll be with you, of course, to monitor this as we move forward in the days to come. As a quick programming note, I do have a live stream coming up this Thursday, which is April 30th at 2 p.m. Mountain Daylight Time. So that would be 8 p.m. in Iceland, UTC. And that will be a live stream broadcast with geologist and YouTube educator Myron Cook. I know a lot of you also follow his channel as well as my own. So that'll be fun for he and I to talk and chat, also to engage you with the live chat, and we can do some question and answer at the end. But I'm interested to hear about his background, how he got started in YouTube education, and then we can talk geology. It'll be a good time. It's always fun to talk with colleagues. So hope you can join me for that, and we'll see you on another video update, or look for other videos that I'm putting out. I'm recycling some of the old ones that have been sitting in the closet for too long, as well as working on some new ones. So thanks again for your support and your time. Appreciate all you do here and your loyal viewership, and have a great day. Take care, team.